So we are doing question JEE 2025 General Organic Chemistry January shift question. Hope सबकी पढ़ाई अच्छी चल रही है and best of luck for coming exam. मेरी तरफ से ये छोटी सी कोशिश है कि तुम लोगों को रिवीजन के समय हेल्प मिले, प्लस जो लोग पहली बार पढ़ रहे हैं उनको क्वेश्चन करने में हेल्प मिल जाए. तो चलो स्टार्ट करते हैं हम पहला क्वेश्चन. द IUPAC नेम ऑफ द फॉलोइंग कंपाउंड इज गिवन. सो दीज आर द 4 ऑप्शन एंड द कंपाउंड इज दिस. When we are solving the IUPAC nomenclature, we have to apply the rules, and COH is a terminal group, so it must get the number 1. Then we can choose the longest carbon chain, 4, 5 and 6. A 6-member chain we are getting, and 6 is connected with the OCH3 group, so we can say it's a 6-methoxy. So we have only in this option 6-methoxy is given. 6-methoxy carbonyl. This CO group is called carbonyl. So 6-methoxy carbonyl. Then we have 2 is connected with the methyl and 5 is also connected with the methyl. So 2,5 dimethyl, and the total is 6 hexanoic acid. That should be the right answer. Let's move to the next question. Given below are 2 statement. So statement 1, these 2 are given and they are saying these are the isomeric compound. So for isomeric compound, remember that the molecular formula same but the structure could be different. So here we have a total 6 carbon. Here also let's count. That is the 1, 2, 3, 4, 5, 6 carbon we have. Even the hydrogen degree of unsaturation is same for both. Degree of unsaturation 1, here also degree of unsaturation 1. So they could be the isomeric compound. This is the ring chain isomers, so that is the right. Statement 1 is right. Statement 2, they are saying they both are functional group. Yes, so this is the primary amine and this is the 2-degree amine, and they do both are the different functional groups, so this is also right. So statement 1 and 2 both are correct. That is 1 and 2 both are correct. Now we are directly jumping to the question number 6 because middle question was the purification, and I'm going to send the separate video for the practical chemistry, so there we are going to cover. Come to the GOC section. So question number 6 is telling choose the correct answer for the option given. These are the match the column, and here this is the table. That is the table. So based on IUPAC we have to find out. So the first one we have to choose the longest carbon chain. We can match it with longest carbon chain. 1 and 2 is there, so 6 and 7 both are there. So 3 ethyl, okay, it is matching with the 3 ethyl. Then 5 is methyl, okay, and then heptane. Okay, so A is matching with the 2. Let's say B is matching with whom? So B, that carbon is in the middle. It has the methyl group both the side, and other side is a propyl group. This side is propyl and this side is also propyl. So the longest carbon chain would be this. This is the longest carbon chain. This is the longest carbon chain. So 3 is here, 4 is there, and one more 3 is there. So the total carbon is 3, 3 plus 6 and 7. Total is 7. So 4 carbon have the dimethyl. So 4, 4 dimethyl and heptane. That should be the right answer. So B is matching with the 3. So B is matching with 3. Okay. So examiner also matched B is 3 in both the option. Let's move to the another one. So here in that question 1, 2, 3, 4 and 5 lowest locking rule 2 methyl. So we are connecting with the 2 methyl 1, 3 pent diene. That should be right. So C is matching with the 4. Okay, we got the answer. C is matching with the 4. And D also we can check. This is the longest carbon chain with the function group 4 ethyl matching with the 1. Your answer should be 1. Come to the next question. The most stable carbocation from the following is. So most stable carbocation, this is benzylic carbocation, support by the resonance. This is support by the OMe, but OMe is creating here minus I effect because meta position 1, 2 and 3rd position. Here 1, 2, 3 and 4th position it is creating the plus M effect or plus R effect, and here it is creating the hyperconjugation plus H. So we know that resonance or M effect is on the top on para position, so 3rd is coming on the top. Then after that we are getting the 4 number hyperconjugated one, and then we are getting the 1 number, and in the end we are getting the 2nd number because of the minus I. So that is the option. So which one of the following carbocation from the following is the most stable? So we have to identify not the order, but we have to identify which is the most stable here. So we can check this has the conjugation. This also have the conjugation, this also have the conjugation, even this also have the conjugation, and it is giving us the plus M effect also, so that higher extended conjugation. Here also extended conjugation, here also not. So this and this is gonna be cancelled. We have to identify between second and fourth. So here you can see this is the EWG group, which is not supporting the carbocation, where this is creating the plus H effect and this is creating the minus I effect, or the minus M also you can observe. So we have a second answer. Second should be on the top and that should be answer. So question is telling identify the correct statement. Here the fill in the blank, this is the OMe group and here is the NHCO Me group, means these two. So they are activating group, and here it is written meta-directing. Activating group act as ortho and para-directing group. Halides are activating group. Choose the correct option for the AES. We have to calculate for the AES. So AES, we know that the plus R effect is activate the group, where minus R effect deactivate the group, or else plus M or the minus M. So we know that OCH3 and NHCOCH3 both are the activator group. These are creating the plus M effect on the benzene ring. They are activating, so this is the right one only. CN and OH are the meta-directing group. It's wrong. OH is a strong ortho and para-directing group. CN and sulfonic group are meta-directing. This is right. So as of now we have A is right and C is right. Activating group can act as ortho and para-directing. Ekdam sahi. This is giving us the ortho and para product, not a meta product. Halide are activating group. No, halides are deactivating. However, they give the ortho and para. So we have A, C, D answer. Answer is. So we have question number 10. It is telling the stability order of the carbocations. So we have to see careful. Phenyl ring is basically stand for the benzene, so which is creating the resonance on this carbon from 3 side. This carbon have the resonance from the 2 side, and this is following the aromaticity. You can observe the 6 pi electron it has, and it is planar sp2 hybrid. Huckel rule is also followed, 6 pi electron, so that is aromatic. Here is only hyperconjugation, that is 3 and 2. These are the alpha hydrogen, so it has 5 alpha hydrogen. So we know that aromaticity, obviously it create the highest stability, followed by the resonance, then hyperconjugation. So your C is, this is your C, this is A, that is B, and this is D. So C is on the top stable, and then after that A we have because more resonance than B. So we can observe this last option, fourth option, C, A, B, and then D. That should be the answer. Let's move to the question number 11, the correct stability order. So here you can observe that is the 2 and minus is stand for the 2 electron, means it has the 4 pi electron, and 4 pi electron is anti-aromatic. It has the 6 pi electron, 2, 4 and minus stand for the 2 electron. 6 pi electron means it should be the aromatic, and it has the 8 pi electron. You can count, but this is the 8 member ring, so that is the non-planar, and that should be the non-aromatic. So your stability order, Q is on the top, then followed by the R and then P. So we have a next question, total number of nucleophile. Nucleophile means electron rich species. So ammonia have the extra lone pair, here the sulfur have the extra lone pair, and this sulfur also have the lone pair. Double bond also acting as a nucleophile because it has the pi electron, so that can be this, this and this. OH minus is electron rich but due to the minus sign. The plus is not electron rich, and this is the ketonic group. This is not a nucleophile, they are acting as an electrophile, so this is not. Here the nitrogen is held by the double bond, so that is also not a nucleophile. So your answer should be 5. Question is how many stereoisomers are possible? So it has the chirality, and this double bond can show the geometrical isomerism because of the restriction and rotation in different substituent. So total stereo centers are 2. So we know that number of stereo center or stereoisomers would be is equal to 2 to the power n, where n is a stereo center and we have 2, so your answer should be 4. Levio cis and levio trans, like this. These are the 4 possibility we can get it. Answer should be 4. So we have question the possible number of the stereoisomers for the 5 phenyl pent 4 in 2 all. So we have to draw the structure, that is pent, 2 is all and 4 is in, and 5 is connected with the phenyl ring. That's a structure. So we can observe this is the chiral center, and that double bond can show the geometrical isomerism. So we have a formula, number of stereoisomers is 2 to the power n, where n is a stereo center and we have 2 stereo centers, so answer should be 4.